Good afternoon to all. Screen is visible. Anyone please reply. Screen is visible and my voice is audible. Anyone please reply. Okay. Thank you, Nitin. Okay. So in last lecture, we have studied general representation of closed loop system and transfer function. Okay. That output is here, closed loop control system transfer function. So today we are going to start next point, rules of block diagram reduction. Give the heading, rules of block diagram, rules of block diagram reduction. Why the block in block diagram blocks are reduced, or where they are reduced, why they are reduced, for better understanding and some complicated concept uh, mutually mixed with the lower blocks and minimum lower blocks or minimum blocks. Here, rules of block diagram reduction. Okay. See, any complicated system, if brought to its simple form of or cancel form, its transfer function can be calculated by a result obtained as. Means you make a 10 to 10 block and also you make a 6 to 7 blocks, but your result will be same. Okay. So above statement, to bring it into simple form, it is necessary to reduce the block diagram, but using proper logic such that output of that system and the value of feedback signal should not be get disturbed. Okay, means you have to reduce the number of blocks, but your feedback signal and output should not be disturbed. This can be achieved by using following mathematical rules. So rules of block diagram, there are total 8 rules to reduce the blocks. Okay, so give the heading, rules for block diagram reduction. Give the heading, rules for block diagram reduction. Rules for block diagram reduction. Then write down first rule, associative law. Write down rule first, associative law, and write down, consider two summing point, TW, consider two summing point as shown in figure. Consider two summing point as shown in figure and draw this diagram here. R1 plus and R2 minus. Here R1 minus R2. Then next R3 plus. Here R1 minus R2 plus R3 is called as associative law, or also addition law, associative or addition. Okay. Now change the position of the two summing point as shown in figure. Here summing point changing its position means R1 and R3 both are plus. Then R1 plus R3 gives second summation R2 minus, here plus. R1 plus R3 minus R2. Output remains same. Okay. So write down and also draw it both diagram. Okay. Then next, consider summing point with a block in between as shown in figure. Here R1 plus R2 minus. Then next R1 minus R2. Here G1 is block 1, means in G1 R1 minus R2. Then next both are plus, means G plus R3 or R1 minus R2 plus R3. Okay. Here output does not remain the same. R1 plus R3, R1 plus G, R1 plus R3. Here minus R1 plus R3 minus R2 means output does not remain same. Okay, write down this. This is associative law. Then rule second for blocks in series. So number of blocks are arranged in series. For example, 4 to 5 blocks are arranged in series. Here will the output will be the here. The blocks which are connected in series get multiplied with each other. Consider a system as shown in figure. R block 1 G1 means R into G1. Then block 2 like a G2 R into G1 into G2 G3. Here output is R into G1 G2 G3. Okay, so these three blocks are compiled R into block in that G1 G2 G3 and output is C of S. Output is R into G1 G2 and G3. Okay. When blocks are arranged in series, calculation will be make as here, means multiply with each other. When blocks are connected in series, get multiplied with each other. Okay, so write down and draw it. Then if there is a takeoff or a summing point in between the blocks, here there is a one sum takeoff or summing point in between the blocks. In between block there is a summing point or takeoff point. The blocks cannot be said to be series as shown in figure. Consider this block not shown into the series. Here means G1 G2 in series and G3. So G1, G2 and G3, they are not connected to the in series. Only G1 and G2 consider as a connected in a series. Okay. In above combination, blocks G1, G2 are said to be in series and can be combined as G1, G2, but G3 not in series with G1 and G2. Why G3 not in series? Because in G2 and G3 in between takeoff point or summing point is added. That's why they are not considered G1, G2, G3 in series. Understood? Write down. Okay. Then rule number 3 for blocks in parallel. For blocks in parallel. In different block diagrams, there are blocks are connected in series, also in parallel. So series connected, we are studied already. So blocks are connected in parallel. Here they are get added algebraically by considering the sign. Means they are added. Here R gives three blocks G1, G2, G3. Then this sign as minus plus minus means minus RG1 plus RG2 plus RG3. Here output will be the C is equal to minus RG1 plus RG2 plus RG3. Therefore, taking R common in bracket G2 plus G3 minus G1. And here output diagram, block diagram will be the R in block G2 plus G3 minus G1 output. Okay. These mathematical description is used where blocks are connected in parallel in different block diagrams. Okay, so write down and draw it. Give the heading rule number 3 for blocks in parallel. Write down and draw it. Here, unless and until the takeoff point is shifted before the blocks cannot said to be in parallel. Also, same as in a takeoff point or summing point in between to the two blocks, there are no, these two blocks are not considered as a series. Here, same also, unless and until the takeoff point is shifted before the blocks cannot be said to be in parallel. Okay? Means here, this takeoff point is shifted to here. Okay? Or also, this takeoff point shifted to here. So, said as these two blocks are not in parallel. This is diagram number 1 and diagram number 2. For a parallel combination, the direction of signal through the blocks is parallel must be the same. Here direction of signal G1 and G2 in opposite direction. Okay. Here opposite direction means plus and here minus. So parallel combination, the direction of signal through the blocks is parallel, in parallel must be the same. This is diagram number 2. So these two diagrams are in the blocks are series, parallel correction. So draw and write down one sentence. Also draw this second diagram and write down this sentence. Okay. For a parallel combination, the direction of signal through the blocks in parallel must be the same. Okay. Then rule number four. Rule number four. Shifting summing point behind the block or before the block. Write down rule number four. Shifting summing point behind the block or before the block. See the diagram. Output must remain same while shifting the summing point. Here output is equal to C is equal to RG plus Y. Okay, these are in series. Sorry, parallel. Therefore, R into G, RG plus Y. Therefore, summation is equal to C is equal to output is equal to RG plus Y. Here output is equal to RG plus Y. This diagram here same. Then this summation point shifted to here. Okay, this summation point shifted to here R plus X into G. Some output is equal to R plus X bracket converted into G. Here output is C is equal to R plus X into G means RG plus XG. Equation number second. Comparing equation first and two. Equation first. C is equal to RG plus Y. Then C is equal to RG plus XG. Therefore, XG is equal to Y or X is equal to Y divided by G. This is equation number 3. So that the signal Y must be multiplied with 1 divided by G to keep the output same. Okay, means R here Y plus sign 1 divided by G, then pass to the second block G. Therefore, C output is equal to RG plus Y. Here RG is the answer, output will be the same. Okay, understood? So rule number 4, shifting summing point behind the block or before the block. Write down here, write down the 4 slides under the shifting summing point behind the block or before the block. Write down and draw this diagram also. Output C is equal to Rg plus Y equation first. See the equation second and equation third. Completed? Next, so the signal Y must be multiplied with 1 divided by G to keep the output same. Here we will get output will be the same. You have to add signal Y multiply with 1 divided by G. Thus, while shifting a summing point behind the block, that is before the block, then add a block having transfer function as reciprocal of the transfer function of the block before, which is summing point, is to be shifted. So in series with all the signals at that summing point to get the desired output without change. When blocks are connected in series, is that all the signals at that summing point to get the desired output without changes. Okay. Then next, rule number 5, shifting a summing point beyond the block or after the block. Rule number 5, shifting a summing point beyond the block or after the block. See in block diagram plus R plus Y in G. So summing point is connected to the G in parallel. That's why C is equal to R plus Y bracket completed to G. Therefore RG plus YG. Here output is C is equal to RG plus YG. Now to shift the summing point after the block diagram, keeping output same. Here this summing point is shifted to the here. means RG plus X. Okay, so C is equal to RG plus X. Here, after shifting the summing point after the block, the output is C is equal to RG plus X. And here, before shifting summing plus C is equal to RG plus YG. Consider these two equations, comparing 1 and 2 equation, X is equal to Y into G. Therefore, R block G, RG summing point in Y, GY. C is equal to RG plus YG or GY. So G is take a common G in bracket R plus Y. Okay. Here G in bracket R plus Y. That is, Y must be multiplied by the transfer function of block beyond which summing point is to be shifted, as shown in the adjoint figure. Thus, while shifting a summing point after a block, add a block which has same transfer function as that of block. Means after which summing points is to be shifted in series all the signals at that summing point. Get it? So here write down rule number 5, shifting a summing point beyond the block or after the block. Write down the next. Comparing equation 1 and 2, we get X is equal to Y into G or G into Y. Comparing equation 1 and 2, the block diagram shown as here, right? Then here, final block diagram of this summing point shifted beyond or after the block. That is, signal Y must be multiplied by transfer function of the block beyond which summing point is to be shifted, as in adjoint figure. Okay. Also, while shifting a summing point after a block or add a block which has same transfer function as that of the block. Means Your block summing point is shifted after the block. Transfer function of block this will be the same. After which summing point is to be shifted in series all the signals at the summing point. Okay, all the signals at that summing point. Then rule number 6, shifting a takeoff point behind the block. Rule number 6, shifting a takeoff point behind the block. Consideration or see the block diagram. R, G gives forward R into G and Y minus. To shift the takeoff point behind the block, value of signal taking off must reaction same. For the above case, the output is C is equal to R into G. That is Y is equal to E divided by. For the above case, the output is equal C is equal to R into G. That is Y is equal to R into G. Here, this takeoff point shifted to here. After shifting takeoff point behind the block, this is takeoff point shifted behind the block or before the block. Here, Y is equal to R, but it must be equal to RG. So as block with transfer function G must be introduced in series with signal taking off after the block. Okay, write down. Just while shifting a takeoff point behind the block, add a block having transfer function same as that of block behind which takeoff point is to be shifted in series with all signals takeoff from that takeoff point. Okay. Here output will be the same. Output is the same. Y is equal to RG. Draw and write down this. Wait, Sushant Jadhav.